Students, we have started the LR circuit. So let us see the calculation for the LR circuit. Okay, so before moving to the derivation, let us draw the LR circuits diagram. In the previous class I shown you all the how the LR circuit will look like. What will be the position for the L, how does the L looks, your inductor. But still, for in today's class I am putting the diagram again. This is the direction of the current I, this is your L part, this is your R part, and this is your V, the alternating voltage. Okay, and since your inductor is there, so obviously there will be voltage drop, and it is marked as VL, and here also there will be a potential difference, it is a drop, and it is denoted as VR. Okay, clear that circuit diagram? Okay, now as usually let us write the applied voltage, the applied alternating voltage, that is this let us write the equation for this applied alternating voltage. So its equation will be as usual V equals to V naught sine omega t. Okay, so since this is your applied voltage, applied alternating voltage, so let us write the instantaneous change in the current in the circuit. Okay, so your instantaneous change in the current in the circuit be denoted as di, because this is your instantaneous change in the current. Okay, so since there is a change in the current, that is your di, so obviously some EMF will be induced. Okay, so the value of the induced EMF in the inductor will be what? Your induced EMF will be L across the inductor will be E equals to across the, yes, this is your EMF, will be equal to minus L di by dt. Okay, this is your EMF. Okay, so the effective voltage in the circuit will be what? Since some EMF is induced in the circuit, it is opposing it, so the effective voltage in the circuit will be what? It is as usually is denoted by the VE. So VE will be what? V naught sine omega t minus L di by dt. Okay, that means this part, this is the net effective voltage that is applied in the circuit. Understood? Okay, so according to Ohm's law, what we can write, what is the Ohm's law? V equals to IR. Okay, so I'm writing it here, that is VE equals to IR. Okay, so where the resistance, if any, of the inductor L is included in R, this equation is valid that if there is any presence of resistance in the circuit as well as the inductor is there in the circuit, so we can write this Ohm's law. This Ohm's law is more or less valid, isn't it? Because here having the presence of both this L and the R. Okay, so what we can write from this particular equation, this is your Ohm's law's equation. So I can write this thing that this V's value as V naught sine omega t minus L di by dt equals to IR, because more or less, yes, see, in the previous step only I have written this, that your VE part is V naught sine omega t minus L di by dt. Okay, so I can just equate these two equations. Here in the last equation I have just equated the two values of VE. That's it. Okay. Okay. So just place it mathematically. That means I'm keeping this V naught sine omega t in the RHS only. So your next step will be L di by dt plus Ri or IR equals to V naught sine omega t. Okay, I can write this keeping, I have just kept the V naught sine omega t in the RHS part. Alright, this will be your equation number 2. And the first equation, the very first equation, that is the equation for the alternating voltage, I am marking it as equation number 1. Alright. Okay. So yes, from this particular equation, what we can write? Okay, so this we have seen the value of the V naught sin omega t is L di by dt plus Ri. Now students, let us assume or let us recall the equation for the current. Okay, in the previous derivation also we have considered this equation as the equation of the current, that I equals to I naught sine omega t plus alpha. Okay, so let us differentiate students this equation I with respect to t for one time. That is di by dt will be equal to, this is only maths part, omega I naught, omega since it's a constant, and it will be cos omega t plus alpha. Understood? The differentiation of sin theta is cos theta. Okay. Okay. So this was the equation number 2. Okay. So now students, now we will put the value of I and di by dt. That means I and di by dt in the equation number 2. Understood? This I and di by dt here we have to put in this equation number 2. So let us see what the equation becomes. Omega L I naught cos omega t plus alpha plus R I naught sine omega t plus alpha, which is equal to V naught sine omega t. Okay. Now let us take the I naught common. Sine naught R sine omega t plus alpha plus omega L cos omega t plus alpha, which is equal to your this thing V naught sine omega t. Okay.